Hello everybody. In this example, we want to calculate the magnetic field due to a curved wire. Now the question says that we should determine the magnetic field at point O for the curved wire shown. Now whenever you're given a complex problem such as the one on the board, the very first thing you need to do is to divide the wire into its various segments. In this case, you have A, segment AB, BC, and CD. But the very first step is we know that dB is equal to mu naught I 4 pi dl cross r cap divided by r squared. So for each segment we will write out this expression. Let us call this segment 1, segment 2, and segment 3. In segment 1, this is our DL. This is DL1, in which case it's in this direction. In segment 2, this is our DL, DL2, which is directed like that. With respect to segment 1, this is R cap. With respect to segment 2, this is R cap. And with respect to segment 3, this is R cap. Now here you have DL3. So if you noticed, DL1 is parallel to R, which implies that DL1 cross R cap is equal to 0. Similarly, DL3 is parallel to R cap, which implies that DL3 cross R cap is equal to 0. What this means is that segment AB and segment CD do not contribute to the magnetic field at O. Now, DL2 is perpendicular to R cap, which means that DL2 cross R cap is just going to be equal to DL2, which in turn will be equal to R d theta, where theta is this angle, that is d theta. So dB will be equal to mu naught I over 4 pi multiplied by dl divided by r squared, which will be equal to mu naught I divided by 4 pi bracket dl is r d theta all divided by r squared. Therefore B, which is the integral of dB, will be equal to mu naught I 4 pi r, the integral of d theta from 0 to theta, which is just gonna be mu naught I divided by 4 pi r multiplied by theta. So B is equal to mu naught I divided by 4 pi r multiplied by theta. Thank you for your time.